So today we're going to work with proportional and non-proportional situations. We're going to determine, just by looking at the information they give us, are the equations or the graphs or the tables proportional or non-proportional. So the first one is distinguishing between proportional and non-proportional situations using a graph. And you'll remember that in 7th grade, a graph of a proportional relationship always passes through what point? The origin. And non-proportional relationships do not pass through the origin. So if a relationship is nonlinear, it is automatically non-proportional, because a proportional relationship has to be linear. If it is linear, it may be either proportional or non-proportional. When the graph of a linear equation contains the origin, in other words, passing through the origin, the relationship is considered proportional. So the graph shows the sales tax charged based on the amount spent at a video game store in a particular city. Does the graph show the linear relationship? So is it a straight line? Okay, so it does show it's linear. Is it showing that it is proportional? Is it going through the origin? And we notice that here, if we were to look at this closely, it's going right through the origin. So this is showing that we have a linear proportional relationship. So the graph shows a linear proportional relationship because it is a straight line that contains the origin. Okay, so it's a straight line that passes through the origin. If I look at your turn number 1, is this linear? Is it proportional, or is it non-proportional? If you said that it's linear but non-proportional, you are correct. Take a look at number 2. Answer, is it linear or non-linear, and is it proportional or non-proportional? We can also distinguish between proportional and non-proportional situations using an equation. If an equation is not a linear equation, it represents a non-proportional relationship. A linear equation in the form of y equals mx plus b may represent either a proportional, where b is 0, or non-proportional, where b is not 0 relationship. So our example 2, the number of years since Keith graduated from middle school can be represented by the equation y equals a minus 14, where y is the number of years and a is his age. Is this relationship between the number of years since Keith graduated and his age proportional or non-proportional? The equation is in the form of y equals mx plus b, with a being used as a variable instead of x. The value of m is 1, because in front of every variable, if there's no number, we know that there's an invisible 1. The value of b in this equation is negative 14. Since b is not 0, the relationship between the number of years since Keith graduated and his age is considered to be non-proportional. Okay? So it is linear, but it is non-proportional. Okay, let's look at the your turn down below. Determine if each of the following equations represents a proportional or non-proportional relationship. If I have d equals 65t, if I were to think of it in the equation of y equals mx plus b, where d is in place of y and t is in place of x, I have a slope of 65, but I do not have a b. But if I did this, b is 0, isn't it? So because there is no B, then the equation is showing us that it is a proportional relationship. When I look at this one, and again, y equals mx plus b, do I have a slope? Yes. Do I have a y-intercept? Yes. So because I have a y-intercept and the b or the p is in place of the y and the s is in the place of the x, this is showing that this is a non-proportional relationship. Okay. Take a look at number 7. It's written just a little different, but we can maneuver some of the information around so that it fits by just rewriting this side of the equation. So if I use my n representing my y, and then this whole section here would be my slope and x, so that would be negative 3p, and then positive 450. Is this proportional or non-proportional? If you said non-proportional, you are correct. Take a look at number 8. Can you rewrite it into the slope-intercept form? Because we cannot, this is nonlinear and non-proportional. So we're going to write non-proportional. Okay. Take a look at the examples 1 and 2 in your notes and determine if they are proportional or non-proportional situation. What do they need in order to be proportional? Take a look at the examples 3 and 4. Are they proportional or non-proportional? These are also found in your notes. This is the end of part 1. If you have any questions, please see your teacher.